Hello everyone. Welcome to the last section of my tutorial on data pricing from economics to data science. In this section, we will wrap up our tutorial. Let me first briefly compare data pricing with some other research areas, particularly pricing data and cloud computing. Then, we will discuss a series of challenges and directions for future work. The research into data pricing happens simultaneously in multiple domains, including economics, marketing, e-commerce, databases and data management, operational research, management science, machine learning, and AI. However, to the best of our knowledge, there exists very limited effort to provide an interdisciplinary survey of the related work. This tutorial presents our effort to produce a comprehensive picture. We will publish a survey article later to provide more comprehensive information. There are some previous studies related to data pricing. For example, there are surveys on the life cycle of big data and reviewed different data pricing models. In that survey, they also discussed data trading and protection. Moreover, there are studies to report a literature survey over 18 research articles regarding several research questions, including maturity of the pricing models and pricing models. In this tutorial, we cover a substantially broader scope than those previous review articles. We connect economics, digital product pricing, and data pricing. We also discuss a series of desirable properties in data pricing, including arbitrage freeness, revenue maximization, fairness and truthfulness, and privacy preservation. We also reviewed the techniques achieving those properties. Data pricing is highly related to cloud pricing, since a lot of data for pricing and trading are hosted on cloud. There is existing survey on cloud pricing models comprehensively. The survey systematically categorizes three fundamental pricing strategies, namely value-based pricing, cost-based pricing, and market-based pricing. Then, they further categorize 9 pricing tactical objectives. Specifically, there are value-based pricing, which is demand-driven, consists of customer value-based pricing, experience-based pricing, and service-based pricing. Cost-based pricing, which is supply-driven, consists of expenditure-based pricing, resource-based pricing, and utility-based pricing. Market-based pricing, which is an equilibrium of supply and demand, consists of free and pay later pricing, retail-based pricing, and auction and online pricing. In that way, the authors cover in total 60 pricing models. While data and cloud are highly related, data pricing and cloud pricing are fundamentally different. Data pricing is selling data, while cloud pricing is selling cloud services such as storage and computation, including physical resources, virtual resources, and stateless resources. In addition, there are different pricing models and pricing themes used by some popular infrastructure as a service providers. Some people propose pricing as a service, which is essentially a personalized pricing service for IaaS. There are also studies to propose broker as a service, which matches cloud services among cloud service providers and users. The key there is to predict resource demands and thus derive prices. As data are often hosted online, one interesting question is that the fair sharing of the cost among data owners, data users, and data brokers. This is related to data pricing because the cost of data hosting and processing have to be recovered from data pricing. There is studies showing the fair allocation of costs in query services. They develop a stochastic model which predicts the extent of cost amortization in time and number of services based on query traffic statistics. The model can be implemented on top of any cloud DBMS. And also, there are studies providing a cost assessment tool to evaluate the cost of a desired data sharing. One useful feature of the tool is that a user can explore the cost space of alternative configurations using various factors, such as quality, stainless, and accuracy. Now, let's look at the challenges. In literature, a series of challenges are identified. The first challenge is the growing number of data providers. That means there is a clear growing number of data providers in data markets. Correspondingly, we need to create information extraction systems that can attach structured, semantically meaningful labels to text data with little human effort. Given that labeled text data enable an analyst overlap operations on web data with the same simplicity as a web search, this is a big challenge. Second, data markets will offer the entire stack of niche domains. Correspondingly, we need to enable analysts to create domain-specific data processing flows with little cost. Therefore, how to enable and optimize black box user-defined functions in these flows becomes a very important challenge. Indeed, the recent development of deep learning and AI already shows the great potential and also the great challenge. Third, customers demand data more quickly. To respond to their demands, we need to build systems that can reliably answer brand monitoring queries to indexes with heavy read and write access. Our service have to stick to the ACIT constraints on a scalable infrastructure in order to enable near real-time brand monitoring. Next, customers will use product substitutes. Therefore, we need to provide such substitutes and also price them properly. The challenge here is that given a list of entities and their properties, we need to identify a set of mining algorithms that have been optimized to a very high degree for exactly this dataset. We need to provide a user with an excursion sample and recommend an algorithm with regard to excursion time, precision, and recall. In other words, we need to have the performance guarantee for the data products and data services. Fifth, data markets will offer price transparency. Therefore, we need to develop incentive for suppliers for price transparency. And currently, the data pricing work focuses on each step, but does not really connect all the steps together to provide the price transparency. Last, data pricing is one mechanism in the data markets. Therefore, we need to learn from customers. That means we need to collect the transactional data from customers and leverage this data for solving the above challenges. In addition to those challenges, indeed, there are more challenges we need to address. First, data as a product or services as products. We need to form the data supply chain, and we need to operate the whole supply chain efficiently. And how to create such a supply chain network and how to make sure the supply chain network of data is smooth, this is a big challenge. And also, at this time, most of the data pricing solutions focus on some individual steps. But to make a data marketplace, we need the end-to-end solutions. The end-to-end solutions pose grand challenges and also grand opportunities. Data pricing is based on data value. Therefore, valuation of data and data usage from different angles are important. For example, some obvious angles include the data providers, users, brokers, and there may be more, such as the commonwealth. We talk about the pricing, and economically, pricing is always associated with accounting and auditing. Therefore, how to conduct the accounting and auditing about the data markets is an important challenge. Last but not least, when we talk about the general techniques, we also need to think about specific applications, because vertical applications may provide unique opportunities but also challenges. Fairness, truthfulness, and privacy preservation in those specific application domains become very interesting and important. Thank you.